Welcome everybody to the mask webinar this morning. It's going to be an action crammed event, hopefully, with lots of participation from all of you. I hope I don't end up doing most of the talking. We certainly have Wendover Brown who will be making a presentation, but a number of you have indicated that you will be able to address some of these questions that we're having. As in the way of introduction, the McIlvaine interviews with Mann and Hummel and AAF covered ambient filtration at traffic intersections and other highly polluted outdoor locations. Based on this vision, should we tell residents of Beijing to throw away their masks? Should we tell Wendover Brown's son in California not to worry about a mask, that we're going to put in filter cubes on that hill and stop the wildfires there? And so, I guess the analogy here is really, should our strategy be to rely on preventing COVID spread with masks, having the following capabilities, which is pretty low efficiencies, leakage. We have big questions, and we'll have some people talking about the droplet evaporation from masks, and we certainly have lots to learn there. So I would say let's start with a survey on mask importance, and I would ask you to maybe volunteer which of these three categories that you believe are the ones you would choose. A, masks to prevent emission are more important than masks to prevent individuals. B, both are equally important. C, the emphasis should be on masks to protect the wearer, but with the secondary goal of preventing emission. So who would like to weigh in on their choices there?
Well, I'm happy to say something.
Good.
We have seen the information change as, the global public health situation has evolved. And it's even changed several times during the last 9 months. But originally, our goal was to provide a tool to protect respiratory health, especially in the face of poor air quality and airborne contaminants. Now, 9 years later, at least in our interactions with the consumer, which is quite close, but only represents a very small percent of the population, the need for protecting both the wearer and others has taken over. So I think, certainly having a highly efficient mask product is probably the most important thing. And the ability to test and provide public trust in the products for their performance and efficiency is very important.
How about others? Anyone else like to weigh in on this subject? In terms of C, the emphasis should be on masks to protect the wearer, but with the secondary goal of preventing emission. I'm thinking in terms there, if you get somebody who has difficulty, wearing an N95 mask, that shouldn't then C be a logical way to proceed, which is the primary emphasis being on protecting the wearers, to try to do as much as we can to protect on the emissions. But if you've gotten somebody who is unable, who needs a mask with a valve or something else to protect themselves, then shouldn't that be our choice? So I think that would be where the C would.
I believe C is very, very important, because in our experience of, reusable masks, especially for respiratory challenged and other people, asthma, mold, environmentally induced illnesses, there are people who are not interfacing with the public. They're not going in a store. The mask wearing has a lot of ifs where you're putting a priority on protecting others. If the wearer is asymptomatic, if the other person is not wearing a mask, if, it seems like the priority should be to protect the wearer of the mask and to provide for interception of droplets in case that mask wearer could be transmitting a virus.
And does a mask with a valve capture the big droplets, even though the valve is open?
In our case, we know that with the exit of moisture and heat from the interior of the mask through the valve has to open under the pressure of your exhalation. So we've seen a few studies on the spray, which seems to be contained fairly closely to the individual, but certainly viral particles could exit through the valve.
But you're preventing a lot of the high velocity of a cough or something like that from going directly.
Certainly.
Yeah.
It's a pretty moot point when the CDC is publishing that vented respirators spread COVID.
Yeah, that. So on that basis, then C would certainly be a way to go, and that could be actually done with the more aggressive testing. If we come up with this saliva test that you can know in minutes whether you're positive, and you're somebody that needs to wear a mask with a valve, but in the morning before you go out, you run a saliva test and have the certainty that you're not transmitting at that point in time, why shouldn't you be able to go out with that valve and be comfortable? And I would say the same thing with people that are in that are working or exerting themselves and so forth. Aren't and I guess what's your experience on that? If you're exerting yourself, how important is it to have that valve?
Yes, we still, because we've sold a lot of valved respirators and they have quite a long useful life, we're still recommending to people who are biking, hiking, able to maintain 6 feet, not interacting with the public or inside or in a workplace or in a store, that the valved respirator will, obviously has a higher comfort level. I mean, for example, my husband takes the dog out for a walk at 6 a.m. every morning. He always wears a valved mask because he doesn't see anyone and it's a little cooler inside the mask.
Well, I think those are all some good points. Ross, did Wendover's slides come through yet?
Yeah, I've got them up, and we can just make me presenter, and I can run the slides.
Okay, good.
Okay, very good. So we'll get.
You want me to do that? I can make myself the presenter.
Oh, you can make yourself the presenter. Well, that's good.
Yeah. Okay.
A lot better having someone who knows what they're doing moving this around. That's for sure.
Yeah. Right. I was just going to briefly introduce, I'm very, very humbled to be able to be part of this discussion because we've spent 9 years trying to develop, the proper reusable mask product that would be protective, first of the wearer and now of others in the environment. So we have 2 manufacturing sites, one in Seoul, Korea, and the other one in Germany. You can go to the next slide. We came into the mask business as environmentalists. We were publishers, and we wanted to develop a tool that would protect health and also stimulate a dialogue about protecting the planet. So our target market was air pollution. And you can see our general uses there. That's just an introduction, but basically we have quite a lot of urban mobility, commuters, bikers, poor air quality. Our very biggest channel is asthma and allergy. Travelers, sensitive lungs groups, I count in chronic illnesses, odor sensitivities, genetic respiratory. And then obviously for outdoors, another reason for a valved respirator, gardening, doing things outdoors that are strenuous, where you can stay 6 feet away from the next person. Okay, you can go to the next slide. We've worked with the leading innovator of filtering media across a lot of applications to develop our own recipe of filter. It is a melt-blown hybrid. And we also have a coconut shell-derived carbon filter that's bonded to a textile. We don't make any claims on the carbon filter, but we do know that it acts as a desiccant for keeping the mask a little drier inside, and at least for a while intercepts some odors. For example, yesterday we have hazardous air quality here in San Francisco, and yesterday I couldn't smell the smoke in a Vogmask. So that was pretty nice. Okay, go to the next slide. One of the, big factors, which, I think the do-it-yourself masks and other face coverings are not addressing is, a proper seal around the nose and mouth. So we know that the filtering efficiency of a mask product depends on a good fit. We've developed 5 different sizes. Wrong size is still the biggest issue. But we are able to test on, basically in the lab on test subjects. We test all sizes. So you'll see, a size small on an adult male is not going to have the same average percentage of filtering, but we are able to do total inward leakage tests on sample test subjects. So these sort of correspond with quantitative fit testing that is performed, in an OSHA compliant respirator safety program on workplace and medical respirators. Okay, the next
just
one.
before you do that, just maybe go back to that for a second, just to kind of sum up again. There, you're talking about leakage in the 1.7 to 7% range, depending on the panel members and conditions and mass type and so forth. So it's that kind of range.
Yes, and we routinely do these tests. The average particle penetration of a 0.3 micromass diameter particle will range in our product across these these subjects. I guess in this round it was from 1.7 to 7.0. So that would be from 93 to 98% efficient for microscopic particles.
And this was kind of oriented to people who are active, I take it, because you've got walking and all those things.
Yeah, those are, what they do is they put a probe through the mask, and then the test subjects perform a series of motions, and especially bending the head side to side and up and down, walking, talking while you're walking, and the chamber is filled with, it looks like smoke. I don't really know what the particle is. But so while those activities are being performed, the probe is measuring the microscopic particle penetration to the inside of the mask.
And compared to someone, say, sitting at a desk or something like that, is the leakage there going to be much lower?
So basically, you know, depending on the activity, if you start to look at the numbers, well, it doesn't actually. These just list all the walking motions. So generally, you know, you want to confirm that the mask is efficient, you know, short of doing an individual quantitative fit test on every single consumer, which is impossible. You want to make sure that across a range of test subjects that the mask will efficiently fit well, which is basically confirming that it does seal around the nose and mouth to protect leakage from the sides and under the chin.
Yeah, that's very helpful.
May I ask a question? This is Abhisek
Sure.
from San Diego. So these numbers are for well-fitted mask or ill-fitted mask?
This is a well-fitted mask that had CE approval, you know, FFP2.
I see.
This is a sample of inward leakage on test subjects that this mask was tested. I think this test is from possibly our organic cotton of 2018 or 17. So those are the percentage of particles that enter the interior of the mask across those motions. So if you're looking at a comparable like line 1, average 1.8%, that's 90, you know, 7.2
I see.
filtering efficiency. So
Okay.
this is acceptable under the EN 149 PPE standards.
Right. Thanks.
Some of the high numbers, though, since we tested a size small on adult males, which barely went under the lips, but we wanted to have, you know, certification on our size small, then the test doesn't do as well since the mask isn't designed for that size face.
Right.
It's just a sample. I mean, we have dozens of these tests. I just pulled one of the samples out of the report to show, you know, the sort of fit and performance evaluations that we're able to do.
And I think the contrast here is, you know, the average cloth mask that just saw some testing that we reported on the last couple of days that they're, you know, something about a 60% leakage. So you're talking some pretty striking differences.
Yeah. Certainly the elasticity of the trim and the fit of the mask to the face is the biggest contributor to filtering efficiency. So for example, in our company, we replace the wrong size, no charge. And we keep revising how people should measure and choose which size to order. But the fit is the most challenging aspect. You know, we found a very strong correlation between height and facial dimension, but you have to keep in mind there's such a wide range of facial shapes and dimensions that the height isn't universal either.
Well, that's very helpful. I guess we could probably move on now, but I think that was well worthwhile to get that additional information.
So Bob asked me to do sort of an update of our progress. We're finding ourselves in, you know, as we all are, in a difficult position with the pandemic and the role of masks in a pandemic. As I mentioned, we came into this business to address, you know, the challenges of poor air quality. And masking in a pandemic is quite a different thing. This is why I'm So happy to be part of this discussion because there are decisions to make to evolve a product to meet the current demands. So we know that the single-use disposables are going to have to do all the heavy lifting. But we have also committed, especially under the CDC guidelines, to no vented respirators, to migrating our customers to no valve products. Certainly, we continue to test breathing resistance, particle filtering efficiency. The filters are tested for viral and bacterial, and we try to source, sustainable materials, since the large amount of mask manufacturing is going to cause another environmental problem. So I guess this is my update. All of the new demand for face covering requirements, our customers are indicating they want to have they want to be assured of the product safety and efficiency. I think our customers are also very concerned about the environment. The questions that we receive from mask wearers are probably a microcosm of what everyone is asking, but people that are new to mask wearing have a lot of questions around breathing resistance, the role of a valve. They think the valve is the filter. And also the comfort of wearing a mask which has highly efficient filter media in the middle. So our business is interesting because we had an export ban on our products from the Seoul, Korea manufacturing site until June 15th. In the meantime, we qualified a second plant, but the first manufactured samples, we haven't released those products to market because we felt an obligation to make sure that both plants were presenting pretty identical products. So while we've trained and qualified and we're ready to move forward, the second manufacturing plant is not currently producing yet. And then with the no valved respirator recommendation from the CDC, we decided that the public education was too big a task to present valved respirators to the public. Where we have someone who has a long-time customer and cannot wear a respirator without a valve, we've established a private sale link so that people can get access to those. But it seems to us that it's time to offer no valve only, especially in light of so much media demonizing valves. So this is a sort of education that we've done over the last 3 months. And basically it tries to explain what a non-valve mask is and what a valve mask is. And this is where Bob and I have discussed biking, hiking, hazardous air quality, mold, dust, and environments for protection of the mask wearer only. So it's very, very difficult to stand on top of a mountain and scream this stuff. So we feel that in order to be cautious and responsible with our products, that presenting a non-valved mask, which has very good breathing resistance and is comfortable to wear all day if you're sitting in an office or working in a store, that's the demand we felt.
So are you saying that you can produce a non-valve mask that does have the comfort level to be worn for long periods then?
Yes, the breathing resistance in our no valve Vogmask is measuring at about the lower 1/3 of the designated safety range. So it's hitting about 10 milliliter column height of water. I've been wearing this very same Flamingos mask, which is pictured here, for the last 3 months. And especially as it conforms to your face, you can wear it all day. I mean, certainly we have respiratory challenged customers that if they indicate dizziness or they don't feel like they're getting enough air, we, recommend they don't use it. But we think the solution for this situation during this pandemic, which may persist for years, is a comfortable mask without an exhale valve.
Yeah, that's very interesting. Do we have any questions for Wendover? Oh, I'm sorry. I used. Do you have some more slides here? I'm.
Yeah, I can just quickly
Sure.
go through. Bob and I were speaking about this. We have innovated a valve that has an open and locked position. In the locked position, there are red letters along the side of the valve that read locked. So we think into the future, we have to test it and then test the masks with that new innovation. But in the future, we will be able to offer a locking valve. We also looked at shrouded valves that actually have a filter media over the valve, but we didn't know how to integrate that to our sort of bringing design to high functionality. So, and the other thing is we continue to innovate in terms of the nose band. We found that elongating the nose band and providing flat plastic ends kept it in place better because it's free in the upper trim. And then obviously we're working on the manufacturing, and the products that we're trying to introduce are sort of a model for find materials that are sustainable, the fit of the mask, the feel of the mask on the person, and the consistency of the product. So then you can just go to the next few slides are just kind of research, but I did want in France, if you go to the next one, we can skip over this doesn't really matter. This is just a reusability comparison of different filter media. So it's a melt blown versus nanofiber. That's interesting. I guess I took out the slide about, that's interesting. I took out a slide. There is a new standard developed in France, which is AFNOR Spec S76-001, which is developed in France. It's not a standard to evaluate FFP2 type filtering masks or masks for medical, but it's a sort of a certification for what they call mask barrier. It's consumer mask products. So under this standard, you can establish reusability and also the filtering performance, which I think there are 2 levels at 70 and 90%. So, sorry, it's my part. Hold on for 1 second. Mark. Okay, sorry. My son's house is burning down. That's why I'm a little nervous having him call.
Oh yeah, right.
Yeah, he's in like 2 blocks from an evacuation zone in the Santa Cruz Mountains. So anyway, under these standards, and Singapore has also developed a consumer mask standard. The goal of establishing certifications for consumer mask products is to distinguish from PPE. Under, the EN 149 with a CE mark as respiratory protective equipment, those products will no longer be able to be sold directly to the consumer because they're going to reserve in this crisis. This is the information that we have. Medical and workplace respirators that are certified FFP2 for those workers. And so it's in the past, over the last 9 years, we've always subjected our products to those workplace standards, KF94, KN95, where we had the ability to present our products to confirm to the public that they met certain safety and performance requirements. But in the future, as the standards for qualifying consumer masks are developed and recognized, that's where we'll direct our attentions. And that's all. Certainly what the value of being here today, and I appreciate anyone's comments, is how we should adjust to health requirements going forward. And we know that, there is an environmental concern as well as the health and safety concern.
Yeah, that very interesting presentation. Any questions that people might have before we move along here? Well, thank you, Wendover. And I think we do want to pursue things like the valve masks and even how that could be tied into some of the testing. If we have the instant saliva testing, you can open your valve once you've tested yourself and know you're not going to be communicating the disease. So I think there are lots of things to pursue in the future. So thank you.
Okay, thank you.
Yeah. Okay, Ross. I guess we'll move back to make me the presenter again.
Yeah. So I switched it over. You might have a message to make yourself the presenter.
Okay. Yeah. I hit that screen to make myself the presenter probably then, right? Yeah. Okay. I think that does it, right? So
Actually, yeah, there we go. Now we see your screen.
Oh, okay. Good. And I think I will move on to the PowerPoint presentation here, and get the slideshow going. Yeah, here we are with a slideshow ready to go. And so the subject certainly today is what is the best mask and to meet all these different requirements. So the goal of the webinar is the fact that there's near universal support for mask wearing in public, but confusion and lack of guidance as to the specific mask selection. As shown on the next slide, there's a model created by the University of Colorado and endorsed by a number of institutions, which is being used to guide individuals relative to risks they are taking in various circumstances, from crowded rooms to subways. The model from that study or research is carried in National Geographic and uses a mask efficiency of 50% for the risk taker and 30% for others in the room, who each occupy 12 square feet of space. If 1% of the population is infected and the risk taker spends 3 hours in the room, his risk of infection rises to 90% according to the model. Those using the model would be encouraged to avoid crowded rooms. Alternatively, the risk taker should be aware that if he wears an N95 mask, his risk of infection goes way down. In fact, if everyone wears an N95 mask, the risk is reduced to just 3%. So there's a pretty stark difference between the cloth masks that people are wearing and a highly efficient mask. And now we're seeing models that people are actually using to make decisions that show this type of advantage. So if you go back to that standard model, and National Geographic allows you to input the material, and you change those mask efficiencies, your risk of infection goes down to just 3% in 3 hours. So it would seem that we, as the filtration industry, are going to be able to leverage this data that is apparently now being accepted to show the advantages of more efficient masks. And I think it's been frustrating to many in the industry that there didn't seem to be any distinction between efficient masks and inefficient masks. But now we have at least some models, imperfect as they may be, that at least show the order of magnitude differences that we're talking about here. So this was just kind of a summary of what I just kind of said here. But so why isn't the N95 mask being used by everyone? Well, lack of communication of the benefits is one big reason. Mask wear protective efficiency is not even considered for several reasons, which are not warranted. Comfort, I guess, we heard Wendover yesterday, a few minutes ago, talking about a mask that can be quite comfortable for long periods. Are there improved versions? Should people switch back and forth between efficient and comfortable masks based on the situation? And then, of course, we have availability. It's been assumed that efficient masks were not going to be available, but now I think we can put that to rest with all the different media that is available. And so the challenges for suppliers are, first of all, designs which are comfortable and efficient with a good fit, and then certainly fit testing that gives you minimal leaks. In fact, before we go any further there, because Wendover had some comments about the leakage and so forth, and we do have some people from TSI on the phone with us here. Would one of them want to comment on, this overall attempt to get fed with very low leakage? You've got the Vogmask with leakage down in the 1% or so. How do you see this going forward, and with the masks that are available now versus the Vogue mask versus other masks that you're working with? Would one of you want to make some comments on that? Well, there'll be an opportunity. Please feel free to interject at a later date as we're talking about some of these things. And then we are going to want to talk about nanofibers and membranes. We have some examples there. But then I think we need to be working with the researchers and scientists to fully understand the fundamentals. What happens to a large cough droplet initially captured on a cloth mask? Abhisek is going to address that, I think, a little bit later here. What is the percentage of virus transmitted through small aerosols? Do we need what we call one-stop testing, where after the aerosol is generated, the mask efficiency is measured over time, so it's not just an instantaneous measurement, and then determine and communicate the cost-benefit relationships to include air pollutants as well as viruses? So let's look at the markets. The health benefits of more efficient masks are already being realized relative to protection against air pollutants. So we have a really built-in market, and the large benefits to reduce COVID could be realized in 2021. Benefits relative to other viruses would remain steady until the next new virus comes along, which in this example could be 2025. So the bottom line for medium makers and mask makers is one way or another, there's likely to be a substantial increase in the market. And if the industry is proactive relative to showing the advantages of wearing masks, that the market will be bigger rather than smaller. And we don't think COVID's going to be a non-issue in the next year or two. And of course, with higher awareness of air pollution, other viruses, just reducing influenza itself is a good reason to be wearing masks. So then the question is, what kind of efficiency in the masks will be required, and how will that translate into the market? And Wendover mentioned an intermediate efficiency mask. Kari, I think, will possibly address that as well. But there is an opportunity for something less efficient than the N95 mask to become widely used and replace the cloth mask and give us better fit and higher efficiency. And so I think there's a lot of work for the industry to do to come up with a range of mask efficiencies relative to cost and availability and comfort, and offer this range and be able to verify the advantages of one efficiency versus another. So the risk of infection compared to the cost of prevention, I think the University of Colorado model is a good starting point, but obviously a more sophisticated version, which, by the way, they're building. But schematically here, that you have the airflow direction is very critical. So if the flow is going from the emitter to an HVAC filter and then cleaned up and then the air is diluted before it goes to the recipient, the virus load is going to be very small. Conversely, if it goes from the emitter in a counterclockwise rotation, the full load is then received by the recipient with no HVAC benefits. So there's more to it, obviously, than just the masks themselves. So the market will be shaped through analysis and collaboration, and obviously the will of the people is what it ultimately comes down to, and the comfort and breathability are important factors, but collaboration among suppliers can result in shaping the basis of true costs. So the McIlvaine company has been involved in trying to help a large supplier of surgical gowns show which was better, a reusable gown or a single-use gown, in terms of all the harm and good it would do for the individuals and the environment and so forth. And as a result of that, we came up with something called Quality Enhanced Life Days. But it's important because it eliminates specific costs, which makes decisions in rich countries different than poor countries. And instead, it's on the whole quality of life. and it can be compared really to decisions you're making about driving in a speed limit zone and what kind of speed limit you set for a particular area. And we've gone up to 65 miles an hour, even though it shaves a few hours of life, maybe a day or two out of our life, and over an 85-year-old lifespan, and we're willing to take that risk. And you'd liken that same thing to a mask. You might be willing to wear a mask or not wear a mask if the risk is only the equivalent of going up to 65 miles per hour. But if not wearing a mask is the equivalent of a 100-mile-an-hour speed zone or a speed limit, or even 150-mile-an-hour speed limit, most people are going to opt for the mask. So it's communicating this kind of quality of life risk that you're taking that is, I think, important. And we have all these factors affecting mask performance that all have to be clarified. And, what happens to the virus, how efficient are the masks, disease parameters, severity and duration, mask media types, mask media availability, the mask physics. Mask cleaning is certainly important. And the reusable masks with various cleaning options become quite important. And of course, they can keep the cost way down. And then we presently have this COVID nationalism, which is a problem that has to be dealt with. The co-benefits of air pollution capture a number of country-specific factors. And then we have the different applications. And the selection of masks will be influenced by the viral load. So this means that the individual will want to wear one type of mask possibly on a subway and another one around his residence. And the mask he wears for dining out will be distinct from the one he wears in a meat packing plant. So all of this really has to be done application by application, country by country. And here we just put up some revenue rankings as we see the needs for highly efficient masks. You've got something like the semiconductor industry, where the efficiency needs are the highest at number one, but it's a relatively small market comparatively. And there are a lot of regional considerations. So we're looking at, say, a specific country like Taiwan, which is the largest producer of semiconductors, has got mid-level air pollution problems, but it's a relatively small country, and all that has to play out market by market. So really, there's a three-pronged program that we are recommending, certainly ascertaining reliable cost-benefit information for every application in every country for each type of individual. Communicate that information to the influencers and decision makers with webinars, magazine articles. We have a feature article on masks that just appeared in International Filtration News, one on filters that's appearing this month, and white papers. And then, of course, for the suppliers, we are generating the market forecasts with individual opportunities. Availability is an important question here. And is there going to be availability of enough media to serve billions of people? And then mask comfort is obviously impacted by the design of the mask and the media. So some of the media that's being available is shown on some of the next slides here. And here is one that shows that the cost of media, Marco furnished this slide, can be nominal per mask, and scrim cost per mask, and for nanofibers can be as low as 2 cents on one of their larger machines. And here we have a number of examples of media that is being is available with nanofibers and others. Kari Lukkonnen of Fibertex, I believe, is on with us. Kari, would you like to just comment on how you see the nanofibers and your role in it at Fibertex?
Yes, so the nanofiber we are now making for the masks, they are mostly used on this type of FFP2, KF94 in Korea, and N95 masks. We see it a little bit less on the surgical masks, and it's mainly because of the sweet spot for the nanofiber, and the efficiency what it can provide is more on the higher side. There might be also coming some new nanofiber applications on the mask and related PPE, and those will be most likely on the let's say the more on the consumer side, very highly breathable masks. So if you look now that FFP2 N95 masks, they are quite for a lot of people they are very difficult to wear. And especially if you are, for example, walking a little bit more briskly, you want to go outside and do something else. These masks, they are very difficult to breathe through. So at least in Europe, where these couple of new mask classes are emerging, allowing a little bit less filtration efficiency than the standard FFP2 or N95, we see that there could be a good use for the nanofiber with the very high breathability segments. What comes to the cleanability of the nanofiber, in Asia, in Korea, where the nanofiber masks have been for a longer time in use, people are actually kind of washing them or cleaning them with with alcohol and other means in daily usage. We don't, of course, recommend it because there's always a risk of contamination. But anyway, those masks can be cleaned, washed at least few times or cleaned by alcohol before they deteriorate. Usually the nanofiber can last, but then the other layers in the mask, they deteriorate a little bit faster. And also on the nanofiber, we see that the production is increasing, so there are several companies investing on the nanofiber production in addition to Fibertex. So if you have any questions regarding to the nanofiber, anybody else, maybe I can answer.
Yeah, questions for Kari. You might just
Hi, Kari.
Yeah.
I had one question. We manufacture in Korea also, and apparently the nanofiber filtration systems for respirators are still under consideration by the Food and Drug Safety Ministry. Is there new approvals for nanofibers for use in respirators in Korea? Do you have any information on that?
Well, it's basically it's a question of definition. So if you look on for example, the European Union, the definition for the nano is something below 100 nanometers, and if you look this nano, what the general name for this nanofiber is a little bit misleading. They are not on the nanoscale, so these fibers are typically over 100 nanometer in dimension, and then several centimeters or 10 centimeters long. So this case in Korea, what they are now talking about, I think this is more related to the solvent remnants in these nanofibers. And then there has been a couple of cases where the manufacturer hasn't been careful enough that they have evaporated also solvents out, and this has been the main concern. So and I think in Korea they have been studying that aspect, not exactly the word nano on the product.
Okay. And also, we were in touch with the French government on nanofibers a few years ago, where without the appropriate cover webs, that perhaps the nanofiber the nanofiber threads, they were uncertain about the size of the threads and whether that posed any challenge to respiratory health.
Yeah, this is again, you know that in this so-called nanofiber, which is actually fine fiber, the fiber length it's usually, if you look on the electrospinning or the other means, electroplowing, the fibers are actually very long, so they are not shredding in the same way. So they are on that format. So if you just give you an example, if you compare the glass fiber, very fine glass fiber used on the HEPA, the risk of this type of shredding is by far larger than comparing to this fine fiber technologies.
I have one more question. Is the source of the nanofiber an important consideration? Like certainly if you know it has a glass source, but in microfiber technology it seems like you know you can have a that there are different sources for, you know, for example, a melt blown filter, you know, that it could be cloth, glass. In terms of the nanofibers, I was reading an article that indicated that it depends on the source of the fibers. Do you have any information on that?
So if you look, there's various polymers you can use for the nanofiber or fine fiber production or electroplowing, and there's a different technologies available nowadays. So you can go from the polyester, polypropylene to PVDF, nylon, and so on, and all of these polymers, they have slightly different properties. So, so for example, the polypropylene nanofiber, it has some electrical charge associated. There's also option that use polycarbonates, which are highly charged, much more higher than the electric melt blowns and so on. But if you look now on the air filtration, including also these mask materials, the most common polymer used is PVDF, okay, which is quite inert material, so it doesn't really discharge. And this is the reason also that many people are claiming that it can be cleaned at least several times.
Yes. Do you, in the PVDF, I saw a study on reusability with the PVDF. Do you, in terms of compared to a melt blown, it seems, do you think that that's the direction that we're headed in terms of respirator filtration systems?
If you look the nanofiber, roughly, if you look on the performance without any charging, it's up to, let's say, you know, the FFP1 level. It gives you the same filtration efficiency and pressure drop. When you go higher on the, you know, on the FFP2 N95 and then the FFP3 and N99, then the nanofiber loose is a little bit higher on the breathing resistance, since yes, there is no electrical.
That's what our testing also indicated. Thank you. I'm so happy to speak to a scientist on the different filter technologies, because our suppliers are indicating, you know, as the pandemic persists, possible shortage of melt blown source materials.
Yeah, all right.
Can I add one more comment?
Yeah, Christine, sure.
Yes. So Christine Sun, Water and Filtration Institute. Actually, we needed to differentiate nanofibers we talked with, and when we talk about the nanofibers for face mask, in this particular market, we actually refer to polymeric nanofibers. Actually, nanofibers, there's different kind. Use like a glass nanofiber and cellulose nanofiber. What Kari referred to is polymeric, and also infiltration field. When we talk about nanofibers, it's not a true nanofiber as defined by NSF. They actually have nanofiber diameter less or smaller than 100 nanometer. But in nonwovens or nanofibers produced by polymeric or melt spinning process, actually what Kari referred to is a very specific technology, electrospinning. So for those nanofibers, not way larger than normally way larger than 100 nanometer. So, and also it's longer. It's really not a nano scale of the particles or some of the threatened or damage for our ingestion system. So it's actually precisely it's called, I think it's ultrafine or submicron fibers. So I just want to make point is that we need to differentiate when we address nanofibers, and also there are different ways to produce nanofibers. Thank you.
Relative to the different ways to produce that, I think one individual that may want to talk for a minute or so here is Vladimir Paserin of VPM Research. You want to tell us over a couple of minutes what you're doing with vapor deposition on nanofibers?
Yes, I can do that. Thank you for the opportunity. Really, this interest comes from the application of chemical vapor deposition onto polymeric foams. I worked at a company where we, for a number of years, were developing a process to metallize polyurethane foams. And in fact, such process is being practiced today in production of batteries, rechargeable batteries. So the very same technology can be applied to metallize other polymeric substrates. And in light of the situation around the world today, the process is perfectly capable to metallize electrospun membranes. So we are looking for partners, basically. The process is demonstrated and it's feasible, and we have laboratory scale demonstration available. But to produce a more substantial unit, we would need some kind of partnership with industrial partners. Of course, if we had a medium like that, it would open up possibilities of high temperature use. Also, maybe restoration or disinfection by heat. You could heat such a medium to even 1,000 degrees. So yes, this is a possibility, and as time goes on, I think the demand for such metallic nanofiber media will increase. And if anyone is interested in getting in touch with me, I'll be happy to provide more information.
And just one more thought on that, selection of the metal can be so based on its antimicrobial aspect as well.
Yes. The process that I'm familiar with is specifically using nickel or iron, because the deposition or the decomposition of the metallic precursors takes place at under 200 degrees C. So you can do it with other metals as well, but you would be using some electroless plating processes. Yeah.
Yeah, that's very interesting. Thanks for those comments. Any other thoughts on the nanofibers before we move on here? Well, let's move on to the outdoor air aspects, because there probably is justification for wearing masks in most countries much of the year, just based on reducing deaths and disease from air pollution. And so you've got pretty large numbers being quoted by WHO, over 4 million people a year are dying because of air pollution. So quantification and communication of the benefits of removing indoor air pollutants as well as outdoor air pollutants are certainly desirable. And there are millions of particles being inhaled by each individual every minute, and we need to understand this in terms of even the outdoor impact of particles that we're breathing in. For instance, we're breathing in 7.5 million particles per minute under one calculation that I made. Kari has made some presentation here based on a number of samples of outdoor particle size. You want to comment, Kari, just on what we're looking at here?
Yes, this is one study made 2014. Just a collection of different literature and measurements all over the world of the average particle size distribution in air in the various places. But you can see that here very clearly that this is by the number, and so the largest amount of the small particles, they are below 0.1 micron range, which is, so the particles are very small. And this is then of course it can be totally different in the very polluted areas. So if you look in big cities where you have a lot of traffic, and the big part of the pollution is actually soot particles and they are typically on this a little bit over than 0.1 micron range. And then of course if you have a dusty environment like you have in China in most part of the year, then of course the particles are larger. But these particles are by the number very small in diameter, but the amount of the particles is very large, and depending on what type of particles you are inhaling, then of course it can have a different impacts on your health and so on.
Yeah, and I think it's it's kind of incredible to think in terms of the fact that you're breathing in all these millions of particles and exhaling them. So a mask is contending one way or another with all those particles. The TSI people are experts in all this. Did you want to make, anybody from TSI want to make some comments about what your experience is with the quantities of particles that you're encountering? Well, we can always get their input later, because I know they do have some, talking to them yesterday, some very good information on all this. Kari, I think here's another interesting slide you might just want to go over briefly too, as to what the source of all these particles is.
So you see that there's a huge amount of all kind of particles and aerosols, and depending on the humidity, heat, environment, then these particles and aerosols they can change the form from liquid to halfway to solid particles and so on. And how they actually interact to each other, a lot of you probably have seen this filtration mechanism, and just on the previous slide where it was explained that a lot of these particles, they are really below 0.1 micron range. So the diffusion model is the most prominent model how these particles then are attached to something else. So it means that they actually agglomerating by themselves to the larger particles, and then moving back and forth on this range, depending on what are the conditions. So this is a little bit The air is really a very specific cocktail of all kind of things what we breathe, and nowadays, depending on which part of the world you are, it can be worse or better. Just this the purpose of this slide is just to show that okay, it's not only the particles, but they're also changing in the form depending on the conditions.
Yeah, and made more complex as you're breathing them in and out as well too. So I think that's a very interesting slide. So maybe we better move on to aerosol generation. And the question that we have is, how much of a cough droplet, as shown on this particular slide, stays on the mask as opposed, and because of the emphasis is that this is the purpose of these cloth masks is to catch these cough droplets. But people don't seem to be answering the questions what happened to them once they're on the mask, and you're breathing in and out past them. There are particles going back and forth. How much of that actually stays on the mask versus going somewhere else? And so under one scenario here, with the cloth masks, ultimately about 80 or 90% of the virus ends up in the air because it's re-emitted from the mask. But that may not even be the necessary to calculate how much is in the coughs, in large cough droplets, when here's NIH basically looking at a lot of different cough droplet analyses, and then in our July 28th alert saying that coughing and breathing has a lot of very small particles, and in fact, take the cough, you've got 42% of them are less than 1 micron. So maybe whether or not the cough droplet even is captured on an inefficient mask is essentially a question. But we've got an expert here with us on droplet evaporation. It's Abhisek Saha. And, we've had some very interesting conversations on this. You want to give us, kind of an overview of how you see the research you're doing and how this might impact all these things, including the droplets on the mask surface?
Sure. Thanks for the opportunity. So yeah, let me a little bit, perhaps let me start with the model we presented, and then I'll talk about the directions the research community is going to or seeing through these days. So in this, this particular work, we wanted to look at two aspects. One is how droplets can evaporate and how far they can travel after they come out of our breathing cavities through any respiratory events, whether it be talking or coughing or sneezing. And the other aspect was what happens to these droplets when they, or how we can model the interaction of these droplets with a healthy person who can end up inhaling them, right? And then how can we develop a model which can take care of these interactions and then give us a rate constant, which will basically show how fast the disease can spread, right? So this particular diagram, actually, you are seeing in the slide right now, that actually shows both these aspects. If you look at the right-hand side, that talks about the interactions, where we basically consider the interaction of this droplet cloud, which comes out of a patient or like a COVID positive person, and that interaction of the cloud with the healthy human being as a molecular collisions. So just like in reactions, chemical reactions, you have molecules which collide randomly and then you have reactions. We consider the same approach over here, and that led us this similarity. Drawing this similarity gives us an approach which gives us some reaction rate coefficients, which you can see towards the end in form of K. That depends on what is the lifetime of the droplet and how fast people are moving. Okay, now of course people motions are depending on whether they are walking or they're running and all these things, which can taken care of from the social science studies. But on the other side, which is more interesting, that is shown in the left-hand side of the diagram, that is how the droplets are evaporating and how long they take actually to evaporate, right? And so then we modeled, which realized that when you sneeze, there, as the previous talks were also showing, that there are a lot of droplets coming out, and they are of different sizes. Now, each of these different droplet size will have a particular lifetime based on this initial size as well as the environment. So we produce this model where you can include your relative humidity of the surrounding, of the environment, as well as the temperature of the environment, and that will give you a time scale or the droplet lifetime, and you can also predict how far they move, right? And then this model at the end, which is at the bottom, this droplet evaporation side and this disease spreading side, they come together, and then that predicts how far the how fast and how far the droplets can travel or evaporate, and that will go into the that will give you the predicted disease spread, or this respiratory disease, how fast they can spread. Okay, so that was this model. Now, as we are talking about droplets, there are a couple of aspects which Bob and I were talking before this webinar started. So people are looking at different aspects now. So for one of the, at least from the fluid dynamics point of view and heat transfer point of view, they're looking at when you exhale the droplets, one of the major question is that we are trying to model here, how far they travel and what is the size of the droplets, right? The other important aspect is, if the virus is, airborne, that basically means when you exhale, the droplets that come up in some micron size, right? And these droplets are not particularly water. They have some salts. So at one point of time, the water part will evaporate. You will only have a clustered, very small particles, which can have encapsulated virus. Okay. Now these particles are very difficult to get rid of, because if your droplets are large, at one point of time, due to gravity, they will settle on the ground. But the small ones, after they desiccate or they become this very, really small size, they don't fall down. So they can have much longer lifetime in terms of being active in air and also being inhaled by healthy people, increasing the chances of infection, right? So that was one side, which we are also extending our current model to take care of this aerosol generated part or aerosol dynamics as well. And there are some other people are also working on that. The other side is, which Bob and I was talking about, is when you exhale the droplet, and let's say you are wearing a mask. Masks are basically porous media, which basically has pores, and these pores acts as a filter. So the idea is your air is going to go through, but all the particles and everything are going to go block. Now the issue is, when you have these droplets, they are liquid, so you can actually squeeze them through the porous gaps. And that could be an interesting aspect here, because when you are exhaling, these droplets are going to land on the inside of the mask, and at the same time you will keep on breathing out on the mask, which basically is going to give continuous push on these deposited droplets. So there is a chance that these droplets can pass through the mask and then become another small droplet on the other side. Of course, the droplets would not be the same size when it landed and when it comes out, but there is a chance it can happen. And it generally happens in porous media. I'm not talking about particularly for masks, but in general porous media, this is how the transport in porous media happens. And the other aspect was also that if the droplet has landed on the face of the mask, it can evaporate. It is water, so let's say it is not going through, but it can evaporate. And when it evaporates, this virus, which is basically nothing but very small particles in the order of 50 nanometer, and they can also become airborne, because those droplets are evaporating. So we don't know if the particles are still staying on the surface, or as they evaporate, the particles can be free and then move around. So I think that there are a lot of focus are going on from the fluid mechanics and the heat transfer community on these areas, and these are still some unanswered question in terms of from the very fundamental point of view, what happens in these events, which can lead to better understanding of how this COVID disease can spread, with and without mask, and even if there are some caveats which the mask might have, even we use them properly.
Well, this is very, very good work, and I think there's circumstantial evidence. The Duke people reported last week that they found more drops emanating from one type of mask than they did from somebody not wearing any mask, which would certainly indicate what you were saying here, that the drops are actually being pushed through the mask. In fact, we in this next slide we just put up rain on a window screen to visualize all that. But your work going forward here, you might just, it's kind of an allegiance of several different universities between University of California at San Diego, and you've already linked up to some other researchers. Is that correct?
That's right. So in my particular group, we are working with University of Toronto and Indian Institute of Science. So three of us in the three different institutes have a little bit different expertise with a good common overlapping interest, as well as with three of us have different kind of experimental facilities, so that we can look into this more detailed. And as I was telling you that now we are looking at, before we were looking at only the airborne droplets. Now we are also looking at what happens to these droplets and if they have these virus-like particles and they are resting on surfaces, as these droplets evaporate, what happens to these particles as well? Do they agglomerate and become a large particle and stay on the surface, or there are chances that they may actually leave the surface because of the surface blowing? And in that case, we can compare the initial mass loading of the particles and towards the, after the evaporation process happened, and see if there is any changes. So that will give us more insight to this, possibility of virus being transmitted from the face of the mask or the inside of the mask.
Well, it's certainly very interesting work, and I hope you'll keep us informed as you move along with this.
Sure.
And it certainly as a conceptually, what you might be coming up with is a kind of relationship with how much of the virus goes directly through the mask, how much goes directly through or around the mask. But in the case that we're talking about here, how much actually gets stopped initially and then goes with the one-stop concept, then evaporates and goes out through the mask. And then again, how much is on the inside of that mask and evaporates and may even go out around. And then, if a cloth mask has got a 60% flow around the mask, it's possible when it evaporates, it could go either through or around the mask. So I think all these things are questions that need answers, and it could be very, very important. So I think that it's going to be very interesting to see how this all develops. Any other general questions before we end the session today? If not, yeah, go ahead.
May I add, if any of you who are listening, if you have any questions about these things and you have any particular ideas in terms of like what kind of testing should be done from investors' perspective, because we always think about, like us being academicians, we think about from the very fundamental aspects. But if you have any particular directions or queries like which we should be able to answer, please do contact me.
Very good. I think well worthwhile taking you up on that. Any other thoughts or questions? Well, thanks everybody. We'll be recording this and just send your links to the recording, and we'll be doing this again regularly. So this is Bob McIlvaine saying goodbye for now.